This is the last video on the total internal reflection problem, and here my dear I just wanted to share with you, this is a kind of this is one of the hot question I have taken from the book, and the question was given. There are three rays, red light, green and blue light. There are three rays, red, green and blue, are incident on the face AB of right angle prism. This is right angle prism ABC. It is incidenting normally, right? So if it incident normally, my dear, I am sure that it will go, the refraction will go straight in the prism. This is the refracted, this is also refracted, and this is also refracted, right? Because since their incident is normally, so after refraction from the prism, they will go straight. Okay. And they have given that the refractive index for material of prism for red, green and blue wavelength are, so here they have given mu of R is 1.39, mu of green is 1.44 and mu of blue is 1.47. This is given. Now my dear, the question asks, out of these three, which color ray will emerge out of the face AC? Matlab, which ray will come out of the face AC? My dear, this can be indirectly, inverse, I can say, which ray does not come out of AC? The ray which does not come out of AC will go in total internal reflection. Ray will not come out of AC cup when the ray will go in total internal reflection, because if ray will suffer total internal reflection, they will not emerge out of AC. I hope it is clear. So here my dear, the very important one, the ray here the ray will emerge question. I said the ray will not emerge out of face AC when they suffer total internal, total internal reflection in the glass prism. Please try to understand, this is very important. The ray will not emerge out of face AC cup. That is, when they suffer total internal reflection in the glass prism, they will not come out of AC. So for TIR, that is total internal reflection, angle I must be greater than IC. This is the condition. Therefore, sine of I will greater than sine of IC. Therefore, my dear, I can say sine I is greater than 1 by mu, because since sine IC is equal to 1 by mu. So here I can write, or mu should greater than 1 upon sine I. I can reverse that. I can take mu here and I can take sine I here. So mu is greater than sine I. Therefore, mu is greater than 1 upon sine I, and sine I is given 45 degree. Here they have given that here this is the 45 degree, because angle of incident in this case will be 45 degree for everybody. This is the normal. Here it is 45. So here is 45. Similarly, this is the normal. Here it is 45. Similarly, this is normal. So here is 45. So my dear, you all know that 45, 45, 90 degree triangle is this. So if this is 45, 100%, sir, this will be 45 because according to geometry of the figure, I have shown so many numericals. So here, since angle of incident on face AC by a ray of light is 45 degree from figure. You can see, because here I will be 45. It's not a difficult task, you all can understand, because it is 45, 45, 90. So everywhere this angle which will go normally and fall here on the surface, it will make 45 degree. So I am sure that I is 45 degree, even they have not given in question. So now my dear, what will be the value? Therefore my dear, mu is greater than 1 upon sin 45 is 1 upon root 2. Therefore this will give me, therefore mu is greater than root 2. Therefore I am writing here, there since mu is greater than 1 upon root 2, because sin 45 is 1 upon root 2, here I am writing sin 45 is, since sin 45 is 1 upon root 2. So here this is, therefore mu is, therefore my dear, mu is greater than root 2. So what is the meaning of this? Whose refractive index is more than root 2? That is, mu is greater than 1.41. I hope it is clear. So जिसका mu refractive index 1.41 से ज़्यादा होगा, they will suffer total internal refraction, because I said for total internal refraction this is all I am doing. So it means that thus the Ri, that is mu of red color and my dear, one more, this is no, not red color, mu of which color? Green color and blue color. Green color and blue color, since thus the Ri mu of green color and blue color, that is mu of G and mu of R, blue, green and blue, that is green and blue color is greater than 1.41, hence they suffer total internal reflection and does not emerge from face AC. So the color, this color, that is blue color, and I hope it is clear that it is given in my diagram, actually given this way. Here it is given blue color, here it is given green, and here it is given red. In the diagram here it given, the diagram is given in the question. So I have not written anywhere, but this is given in the question, blue, green and red. So the Ri of mu of, that is Ri of green color and blue color, that is mu G and mu B, is greater than 1.41. So if it is greater than 1.41, my dear, I said if it is greater than 1.41, they will suffer the total internal reflection. I prove it. Because light ka Ri, if it is greater than 1.41, according to question, because it is falling at incident of 45 degree, so answer is coming mu greater than 1.41. So जितने लोगों का mu is more than 1.41, they all will suffer total internal reflection. So here blue color will suffer total internal reflection, Even green color will suffer total internal reflection, my dear. Now I am giving the answer for the question. Whereas my dear, red color, since the Ri of red color, I am rubbing it out. I am rubbing this. Since mu of red color is less than 1.41, hence red color ray will emerge out from face AC as an emergent ray, bending away from normal because it is coming from glass to air, so it will be bending away from normal as shown in figure. So this is for red color, and here my dear, this is a red color. It will be emerge away from the normal like this. And this is your normal. So here it's emerging away from the normal. Here it is not grazing. Here it's not grazes the surface because probably the critical angle of this surface is something more. Is more than 45 degree. So here it is refracted out. That is not given in the question that how much is the critical angle of this surface. But my dear, here the answer for this I am getting that the refractive index I calculated, that the refractive index if greater than 1.41, then it will suffer total internal reflection, because I put the condition for total internal refraction that I should greater than IC for TIR, and I calculated with that way that mu should be greater than 1.41. With that I came to know that only two rays is having mu greater than 1.41, that is green color and blue color, and therefore they will suffer TIR, they will not come out of AC. वो TIR में चले गए, तो वो AC से बाहर आए नहीं, TIR total internal reflection में चले गया. But one light, that is red color, having a wavelength of 1.39, whose refractive index is less than 1.41, and hence this color will emerge out of the face AC as an emergent ray bending away from the normal. You can see it is bending away from the normal, and this is called your angle of emergence. So I hope the question is clear from HOTS. This is one of the question taken from the HOTS. Now let's go to the two NCERT numerical. One is the same type and other is on the optical fiber.
अरे अब तो घर वालों हेल्थ इंश्योरेंस policybazaar.com से महंगा नहीं है. policybazaar.com health insurance standard terms and conditions apply.
Now look at this, is an NCERT problem, as we have done such type of a problem earlier also in my video. You can see a small bulb is placed at the bottom of a tank containing water to a depth of 80 centimeter. Here is the depth is given as 80 centimeter, that is in data. You can say data H is equal to 80 centimeter, that is equal to 0.8 meter. What is the area of the surface of water through which the light from the bulb can emerge out? I said this area is nothing but in the form of a patch of a circle. You can see because of the refraction which is occurred due to this point source. Am I clear? And this area we are supposed to find. Now my dear, once again draw the diagram here for the question. This is the, say, a beaker containing water, and here is the, I drawn the surface. Okay, Now my dear, you all know that this is mu of water is given as 1.33. That is the mu of water is given, and 1.33 can be written as 4 by 3. Please have an habit of writing mu of water. That is, mu of water is given as 1.33. That is nothing but 4 by 3. So my dear, this is what is the data given. Rest all is, and here is the point source of light, that is bulb. This is a bulb as a point source of light, and I will take it as S. Now you all know that the light from here, it will be go here. The light from here, it will go here. You all know this is incident angle. Here is, my dear, we get the patch due to the refraction from the point source. Like this is the point O, my dear. So you all understood that what is the area of the surface of water? This is the area, my dear. This is the area of surface of water through which light emerge out. यहाँ से light emerge out होएगा. बाकी यहाँ से sir, what will happen sir? This will be a normal on the surface. I can draw. So here is your IC. That is, I become IC. Similarly, here also I can draw the normal, my dear. The same story, I have done so many numerical on this. Here is also IC, and that is equal to I. I hope it is clear. And this is the H. We all know this is the depth of the point source of light from the surface. This is your H, and we all know that this is your R. Here, my dear, when I become IC, when I is equal to IC, when I become IC, my dear, this ray will be refracted at 90 degree. Similarly, here when I is IC, this ray will refracted at 90 degree. That's a question. So now, my dear, here you all know that since mu is equal to 1 by sin IC, or sin IC is equal to 1 by mu, that is equal to 3 by 4, because mu is what? Mu of what? Mu of water. This is mu is equal to mu of water is so much, so it will be 3 by 4, reciprocate. Similarly, my dear, cos IC is under root of 1 minus sin square IC. That is nothing but under root of 1 minus 3 by 4 the whole square. So this will be nothing but cos IC is equal to under root of 1 minus 9 by 16, and it will go like this will be root 7 by 16, and this will be root 7 by 4 cos IC. What will be tan IC? Tan IC, why I am finding tan IC, let me tell you. From figure, here I can say, from figure, ये पता होना चाहिए why I am finding tan IC. हालांकि I have done these sums, so you please check it out. From this surface, यहाँ से ये surface of water से the light will come out. Rest all, it will be total internally reflected as soon as IC become I and I greater than IC. जैसे ही I, अभी I IC पे यहाँ पर है, I and IC are equal. जैसे ही I become greater than IC, the light will reflect it. So only this is the area which is cause refraction, and this point source will emerge out. So this is the area of surface of water through which this light will be emerged out. Rest all will be internally reflected. Okay. Why I am finding 10 IC? You can see in the figure, my dear. Here in the diagram, here it is IC. Because this is IC, then this will be IC. So you all know that from figure, 10 of IC is equal to opposite side upon adjacent side. Opposite side is R and adjacent side you can see in figure H. That is from figure. So my dear, therefore R is equal to H10IC. This I will put it as equation number 1. So my R is radius is because I have to find area. Na? Area is of this patch will be pi r square. I can calculate area only when if I know R. So R is H10IC. So in 10IC, that's why I am finding. And 10IC is sin IC upon cos IC. That is nothing but 3 by 4 upon root 7 by 4. So this is 3 by root 7. So now my dear, R is equal to H10IC. We all know this is H10. IC is 3 by root 7. Or I don't need for going with this step, no issues. Let us go for the direct answer for it. Because you all know that the area I will to calculate. The important is area, not the radius. So let us find area only. So area of surface, that is nothing but circle, because surface is act like a circle, you can see, is pi r square. That is pi and r is your H10IC the whole square, because since r is equal to H10IC. This will be easier for us. So now my dear, therefore area of surface, that is circle, is nothing but pi H square 10 square IC. That is nothing but my dear 3.14 into H square, that is 0.8 the whole square, because H is 0.8, into 10 square IC, that is nothing but 9 by 7. Because 10 IC is 3 by root 7, so 10 square IC will be 9 by 7. And the answer of this will be 2.58 square centimeter, which is approximately taken as 2.60 square centimeter in your answer in NCERT, or you can leave at 2.58 square centimeter. This is, my dear, your NCERT problem number 5 of your exercise. I hope it is all clear, because I have done such numericals earlier also. It is a kind of a practice, my dear. Just do a practice, because these all sums are very important with the TIR concept, that is total internal concepts. Okay. Well, my dear, this is the last question based on the total internal reflection related to optical fiber. Now the question is a beautiful question. This question carries the two concepts. One is a refraction. Here you can see incident ray in air going in glass, that is in core of the fiber, that is denser medium. So here it is a refraction taking place, and this is the axis of the pipe, because they have said the angle of incident ray with the axis of the pipe. So even angle I is with the axis of the pipe, because the dotted line which I have drawn is the axis of the pipe I have written here. So angle I is made with the axis of the pipe. Right now that axis of the pipe is act as a normal to the optical fiber. So here this is axis is acting as a normal, and here is the incident ray making angle I, and here is a refracted ray, because first it is refract and now from here it is reflect. So here it is a refraction. So my dear, here what is very important, we should know that how much is the critical angle. Because unless and until I don't know critical angle, how can I come to know that what should be angle I? Because my dear, see, for TIR we should know that I should be greater than IC. जब मैं ये बहुत बोलता हूँ कि TIR के लिए I का angle, instead of angle, right, should be greater than critical angle. So I think पहले हमको ये पता होना चाहिए that how much should be the critical angle for these two things. For Ri is 1.68 and Ri is 1.44. You all can understand, inside it is 1.68 and outside it is 1.44. This one. That is, core is 1.68 and cladding is 1.44. It is nothing doing with air. Air is something different. As I said, there are two concepts here in the topic. One, it is going with air to denser, but in denser there is a core and there is cladding. This core and cladding, this is array of cladding. Is 1.44. Right, I have taken this as mu c, and this I have taken as, or there is a light pipe, the outer covering of pipe. That I have taken this as outer one. That is mu of outer is 1.44, and this is mu of inner. Mu of inner is 1.68. My dear, this two will decide what is the critical angle of this surface, because unless and until I was knowing IC, I cannot say now I greater than IC है या I less than IC है. तो पहले ये पता होना चाहिए how much is the IC for this question. Please, first you have to calculate IC for this two surface, that is two coverings, that is outer covering and inner covering, will give us the IC, critical angle for the surface. So first answer here, first of all, let us find critical angle of incidence for given fiber material. Please, for given fiber material, I am nothing doing with this air. This air, nothing doing. Fiber material से पहले critical angle निकालना पड़ेगा, because that will decide कि if I greater than IC, then entire light will be total. Because the question is, what is the range of angle of incident? This angle, so that if the light will come with that range, every time inside the fiber it will suffer TIR. Total internal reflection inside the pipe takes place. तो I, ये जो I वैल्यू है सर, ये जो यहाँ इंसिडेंट हो रहा है, इसका क्या रेंज होना चाहिए, क्या रेंज होना चाहिए? That's the question. Am I clear, my dear? So first find out what is the critical angle of fiber material. So critical angle, my dear, you can calculate by outer and inner. You all know that light is going from in to out. That is, light is going out from in, mu O upon mu I. This is nothing but mu O upon mu I. That is equal to, what is angle is made in I? Sin I. Inside angle will be I. Outside angle will be R. If के बजाय you say when, please, this is inner and this is outer. When, this is for material I am calculating, when I is equal to IC, R is equal to 90 degree. Therefore, this is mu out upon mu I is equal to sin IC upon 1. Therefore, sin IC is equal to, my dear, mu O upon mu I, and that is mu O is 1.44, mu I is 1.68. The answer of this will be 0. Let me check it out. The answer for this is coming as 0.8571. This is 0.8571. Therefore, IC is equal to sin inverse 0.8571, and this will give me, my dear, 59 degree. So I calculate the IC for fiber material with this 2 refractive index. Please take care. This 2 refractive index, this is for outer and this is for inner. With the help of this 2, because the light will go from denser to rarer for total internal reflection. and therefore I have considered here that the light is going from denser, that is inner. Please use the concept. Light is going from denser. Denser means inner because it is 1.68 to outer, that is 1.44. So this will be written mu by mu I, sin I by sin R, because inside it makes angle I, and that I will become IC inside. So now my dear, I calculate my IC angle should be 59 degree. So now for total internal reflection, I hope this is clear. A beautiful question. So first of all, I should know IC of the fiber material, which you will calculate by the two Ri given, that is outer covering and the inner covering will help us to calculate the IC, that is critical angle for fiber material. Fiber material. ये मटेरियल जो है उसका क्रिटिकल एंगल सरफेस का निकाला इसने, प्लीज, एंड आप देख सकते हो. एंड व्हाई आई हैव टेकन इनर टू आउटर, मतलब इनर टू आउटर कवरिंग, बिकॉज सर इनर इज डेंसर and outer is rarer, and for TIR the light should travel from denser to rarer, and therefore I took from inner to outer because inner is denser. You can see the mu, and then I substituted Snell's law, that is I have taken Snell's law, mu upon mu I, that is sin I by sin R, because in inner it will be I angle, that I become IC further, because I have that I become IC for critical angle, R become 90, and I calculate the critical angle of incidence. That's beautiful. So now for total internal reflection, I angle, the incident angle must be greater than IC. That is, I must be greater than 59 degree. ये तो confirm. I hope it is clear that I should be greater than 59 degree for TIR. Then only the total internal reflection inside the fiber will take place for any angle which is greater than 59 degree. Am I clear? Now let us calculate what should be the angle of I. What should be the range of I? Now my dear, here you can see in triangle ABC of figure. My dear, I am draw the triangle. Here this is I, so there it is with the axis, this is R. That is R plus IC plus 90 is equal to 180 degree. Therefore, R plus IC is equal to 90 degree. Here R is the angle of refraction. You can see. Am I clear? And axis is act as a normal. So this is refracting angle. And this is the right angle triangle, you can see. So R plus IC plus this 90, R plus IC plus this 90, any triangle is of 180. So R plus IC is 90. Therefore, my dear, therefore, this is R plus 59 is equal to 90, and hence, therefore, R should equal to 31 degree. So by using Snell's law, my dear, light is going from air to denser. When light travel from air to glass fiber, air to glass fiber, when it is going in air to glass fiber. So when I go for this, my dear, this is mu of glass fiber with respect to air, that is nothing but sin I, because air mate is I, divided by sin R. And my dear, I hope mu of glass fiber is taken as 1.68 because it is inside material. Since mu of glass fiber is 1.68, that is inner, that is mu I, because outer is out, inner is the glass fiber ना, अंदर जाएगा ना, यहाँ अंदर की बात है ये, है ना, अंदर की बात है. So this is mu of inner ना. So here this glass, here I have written glass is actually a glass fiber, that is mu I, because light going in mu I. You can see figure here, it is going in mu I. So it is going from air to mu I, air to mu I. So if it is going from air to mu I, that is air to glass, this is sin I by sin R. Therefore mu of glass fiber, where mu of glass fiber is taken as 1.68. because it is going in this area. And why this was given? Sir, this was given to calculate the critical angle of the fiber. Please, that's a conceptual question, a beautiful question. So here, my dear, I hope this is, I think you can now solve the answer, that what should be the answer for the question. So here it will be, mu of glass fiber is taken as 1.68 is equal to sine I divided by sine R, that is sine 31, because R is 31. Therefore, sine I is equal to 1.68 into sine 31, and this will result in the answer, my dear. This is 1.68 into, let me check out, sine 31. Sine 31 is 0.5150. 0.5150. So my dear, therefore sine I, the answer of this, if I calculate, this is 0.8662. Therefore, I is equal to sine inverse of 0.8662, which is nearly to, my dear, 60 degree. Which is nearly 60 degree, my dear. So I hope it is clear that angle of incident in the air medium, in the air, should be 60 degree, my dear. Am I clear? To have total internal reflection. So what is that? The question here is, what is the range? They are asking range. Please try to understand. They ask range. So what is the range? How I will write range? So writing the range is not difficult. I will write here, thus the range of, answer here, range of incident, thus the range of incident angle with the axis for which TIR takes place is 0 less than I less than 60 degree. Maximum equal to 60 degree, you can see. Matlab I should greater than 0 or it is less than equal to 60 degree. Matlab that is, it is either equal or less than to 60 degree. So this is the range of the angle of incident, my dear, for which the TIR will takes place. So that's a very important statement, that the range of the incident angle with the axis for which TIR takes place is 0 is less than I. Matlab I should be greater than 0, but it should be less or equal to 60 degree. That is the maximum angle of incidence, that is 60 degree. I hope it is clear, for which, my dear, the TIR will takes place. Otherwise, the TIR does not takes place if the angle will be more than that. Because here it is given, I should be either less than 60 degree or equal to 60 degree. At the most, maximum angle of incidence is 60 degree for TIR to occur. I hope it is clear. If it is going beyond that, then there will be no TIR occur. That is what the question said. So I hope it is all clear. This is a wonderful question, my dear. Again, let me explain you 2 points here. One is that there is a mu of outer and the mu of inner was given. This mu of outer and the mu of inner which is given is used to calculate the critical angle of the surface, that is fiber material. And how will we do that? Any critical angle, my dear, or any critical angle takes place when it is go from denser to rarer. So here denser is become inner and outer is become rarer. So here it is the light going from inner to outer, that is denser to rarer, and therefore by my rule this is mu upon mi, that is sin I by sin r, because in inner side I have taken I, which is in critical angle here, and r is your refraction, but for when the angle of incident become critical angle, refraction become 90 degree. So that's why I substituted, and this will help me to calculate critical angle of incident. Next, my dear, the second concept is that for total internal reflection, why I did IC to calculate, because I have to calculate angle of incident in this rarer medium. So पहले तो ये पता होना चाहिए कि critical angle कितना है, तो ही मैं बोल सकता हूँ कि I अगर उससे बड़ा होगा तो ही TIR होगा, नहीं तो नहीं होगा. So my dear, for total internal reflection, I should greater than IC, that is I should greater than 59 degree. And I am getting 60 degree, you can see, so it will be TIR. So in triangle, now I have drawn one triangle here by my total internal reflection, you can see. So in triangle as a figure, here is the refracted ray, because here the incident ray takes place in air and going in glass. And glass may be kiske paas? Mu I ke paas, that is inner material, not the outer. Please don't take mu at the outer for this question, because here it will be, this surface will be take part. Inner part, that is inner RI will be considered, please. So that's what 2-3 concepts are there. So in the figure, R plus IC plus this 90 become 180, so R plus IC become 90. Here this will help me to calculate angle of refraction, that is 31 degree. Now my dear, I can use the Snell's law in this area, I and R ke beech mein I can use the Snell's law. Now here when I am using the Snell's law, light going from rarer into the glass, I hope it is clear. So here I have written going from air in glass, answer will be sin I by sin r. And here this glass is actually a glass fiber whose Ri, that is inner material, whose Ri is 1.68. As I said, don't take outer one, that is for calculation of IC they have given. Don't take that part over here, because you will confuse here which mu are supposed to take. You see my dear, here the light going to which surface? Here inside one. So inside matlab this Ri is supposed to be. So glass fiber is 1.68. So I have taken 1.68 here, right? This is sin I divided by sin 31. So sin I is equal to 1.68 into sin 31. I have calculated sin 31 from logbook. Logbook it gives 0.5150. I multiply with that 1.68. I got 0.8662. Again I use the logbook to see how much is the angle. But my dear, let me tell you, this is the maximum angle of incidence, 60 degree. So what is the range? 0 to I, and should be less or equal to maximum to 60 degree or less than that, then only the TIR will take place. That's all from my side, my dear. Thank you very much, and Jai Hind you all.